Hello and welcome. This is Bo Andersen speaking. I just wanted to go through a sub program that I've written for MACH3, a script that essentially picks up a number of tools from my automatic tool changer and probes them twice on a fixed touch plate, and writes the offset of the tool length inside the database. So I'll try to go through the program. There's another video where I show how it's actually performing on the machine itself. So this is the videos to complement this and vice versa. So yeah, this is basically just some information on what I wrote. So the DRO is the digital readout, and the MC is our machine coordinates. These abbreviations are used throughout the document. So my machine is homing in positive, so all my C machine coordinates are negative values. And you'll need one input for the probe, and that must be set up in Mach and attached to the fixed touch plate. And I use a different coordinate set system. In this program I use coordinate 254. I hope nobody else uses that, otherwise you can change it in the settings, of course. But this is in order to make the tool length calculation work correctly, so I needed to use a different coordinate system. Tools with a tool number equals 0 is not supported in this macro, so 0 is a no-go, and that is because when MACH3 starts up, it always starts up with 0. So in order to prevent any unforeseen things, then I say tool 0 is simply not supported. So you need to have a tool in spindle and not being 0. So maximum number of tools on my changer is 8. Then I just make some variables: first tool number, last tool number, and current tool. So this is the first one to probe, this is the last one to probe, and this is the current one being processed. So first tool could be number 3, and the last tool could be number 5. So that means it will probe 3 through 5. So 3, 4, 5 will be probed. If you only want to probe 1, then you simply just enter 3 when prompted, enter 3, and enter 3 as the last one. So if those are the same, it will only probe number 3. Then I do some safety checks. Is the probe enabled? Yes. If it is, then continue. If not, somebody write a message on the screen: somebody forgot to enable the probe in settings, and exit out of the subroutine. Different safety check: is the fixed touch plate already active or grounded? If so, then exit out of this one. Engineer to the bad probe, you are grounded. A different safety check: is the spindle on? So you cannot probe, obviously, when the spindle is on. That would make a mess. Again, a message: you can write whatever funny stuff you want to do here. Last one, safety check: wait for any movement to complete. So that's a while it's moving. Scroll down. So here we prompt the user for the first one to probe, and here I'll make a while statement: as long as you enter 0, or as long as the first tool number is higher than the maximum tool number, then you'll be in this loop. You'll need to enter a valid number between 1 and the maximum number of tools that you specified earlier, which was this one, maximum number of tools. So the user is prompted. Then we prompt for the last tool to probe. Again, you have to select one that is higher than the first one you selected. You cannot select number 5 and then number 3. So you have to enter 3 and 5. And it has to be lower than the max number of tools. So tool number first tool to probe, second tool to probe. Then I create a loop for processing the tool range. So here I set the current tool to the first tool number. Then I deactivate the C tool length offset. That really bugs me a lot. This one, it took me a heck of a time to find out why my code wasn't working. So if you are to do something with the tool length offset, do yourself a favor and cancel it or disengage it as the very first thing, and then once you've done whatever you need to do, re-engage it again. Otherwise it would be a mess. It was to me, at least. If the first tool number is equal to the last tool number, so it's only one you need to do, then call the probe sequence, and then go call a subroutine called probe, and send the value current tool number to that subroutine. Well, if you entered something differently, that the first tool number is not equal to the last tool number, then as long as the current tool number is different from the last tool number plus 1, then go to the subroutine. And this while loop different than the last tool number plus 1 creates a routine that goes through 3, 4, and 5 in the tools, and every time it's different, it simply adds 1 and then call the probe current tool num, and once it's done, it returns from the subroutine and then executes this one and then add 1 to the current tool number. So current tool num is equal to current tool num plus 1, so it simply adds 1 to it and then goes back up in the while when loop. So this is the while loop. So every time it comes back from the probing routine, it adds 1, checks it again, and then calls the probing routine. So this is how I keep adding 3, 4, 5 in this one. Yeah, so this is so once all the tools are done, it goes out of this loop. It simply reactivates the current tool length offset with the current tool. It waits for the DRO to update, and then end of the main program, because the rest is written as subroutines. So let's say that we enter 3 as our tool in spindle and 3, 4, 5 to be probed. So that means that the first tool number is not equal to last tool number, so it goes here and say as long as those are different, and we just specify that the current tool number plus is different from the last tool number plus 1, because last tool number is 3 plus 1, so that is 4. So 3, now I'm making a total mess of myself. Current tool is number 3, and the last is 5, plus 1 equals 6. So 3 is different from 6. As long as it's different, call the probing routine, and that's where we'll go now. So this is the probing subroutine. We say sub probe, so that's the same as this one, and we call it with the current tool number. So the current tool number is the tool that we want to process. Now a subroutine is a program within a program, so it doesn't know all the variables from the other main program, so you'll need to specify variables here also. You cannot specify that outside of the subroutine. So I have an X and Y position, which is the X and Y machine coordinates of the fixed touch plate. I have a C probe start saying a -100 machine coordinate is where I'll do the rapid move to, and then from there on to a maximum of -165 is my probing maximum distance. It will retract 2, in my case millimeters, between first and second probe run. The first probe feed will be 300 and the second probe feed will be 50. And my coordinate system number to be using is 253. I think I said 254 earlier. Right, so I'll get the current feed rate in a variable, because then I can reset the feed rate to whatever it was when I'm done with this routine. So now we called the subroutine with the current tool. We set some variables. We rate the feed rate, the current feed rate, and then I put in some messages, and that is because those are very handy when you are debugging it. So write in a lot of messages with all the kinds of variables, and what it does is it says message. So write a message on the screen. It will write current tool num equal space, and then it will add whatever the value of this variable is. So the current tool num variable is equal to 3, because 3 is my current tool. So on the screen it will simply show current tool num equal 3. Right, so I need to do a tool change here, and what I try to do is to make a code and say M6 tool, M6T, and current tool number. So the number is 3, so the code would be M6T3. Now that is calling a script within a script, and that went totally down the drain, because the coordinates and numbers and everything simply got messed up. And if you read on the forums around, they all state, don't call a script from within a script, it will go bad. And it did. So that I just left it in here as a warning, saying you cannot call your normal M6TXX here, it will go bad. So what I needed to do is simply go over the creek after water, saying I'll need to put in my entire tool change routine inside this script. So call the ATC, call my automatic tool change with the value of current tool num. So I will jump down to my ATC routine, and the current tool num is 3. Call, here it comes. This is my tool change routine, and here we have the subroutine ATC with the tool number 3. So this is more or less a copy of what I have for the M6 routine, M6 start. So I have the new tool, I have the old tool, work coordinates, XYZ. I specify some values again. So the new tool is equal to my current tool num, and this is because I need to map my current tool num into my routine of the M6 program, because I didn't use the same variables. Yes, that is something that could be updated. So the old tool is the one in spindle, tool in spindle. Work X, I read the work coordinates of X, Y, and Z from where the tool change was initiated. I really don't need that for this probing routine. Again, maximum number of tool is 8. I have a tool traversing height when I change between my tools. When I placed a tool in the holder and I need to traverse to the new tool and pick it up, that's the safe traversing height. Then I put in some safe C, so when it goes to the top I just put -5, so I had a little bit of extra space. This is almost top of my C movement. So the drawbar is on output 11, and my air blow for cleaning the tapers is output 12. I put in some X position, Y and Z position where my tool holder will be. Those will be updated with real values. So now my bed type tool changer is a sliding one, so it will have to go down to a C position and then slide in the tool holder in the it will slide in the tool holder of the bed. So this is where the sliding position starts as 570 and slides into 620 or something like that. I think it slides around 50 millimeters. So here my routine states that while the old tool is equal 0 or the old tool is larger than the maximum number of tools, then it will ask, it's an invalid tool number in spindle. You have to have 1 through 8 in the spindle, otherwise it doesn't know what to do. So again, this is coming from my original M6. So if the new tool is 0 or the new tool is larger than the max tool number, say invalid tool number request, and then I make it writes a message invalid tool number request, because it has to pick one between 1 through 8. If a tool request is coming saying I need tool 30, what should it do then? It only knows tools 1 through 8. I make a code M30 and stop the entire main program, and that is because if I was to key in and say, oh, you requested 30, but which one do you want to pick up? I want to pick up number 6 because that was what I meant. Then the tool length offset could be wrong and could be different. So I chose to say I want to stop the entire program here. If the new tool is equal to the old tool, then exit the sub, because then you don't need to change. Simply jump out of this routine. You could put this in earlier if you wanted to, but yeah. So now I say code, and that means it will execute it will execute G code. So it will say code G00, so that's rapid move. G53, that is in machine coordinates, and the C. So rapid move, machine coordinates, C axis to the value of save C. So that is to the -5 millimeters. So that's almost to the top. So that's a traversing, safe traversing height. So now we need to place the old tool in the bed holder. And to find out where that tool is placed, I'll call yet a new subroutine to get the position. And here I call the subroutine tool position, and I'll need to call it with the variables of the old tool, the X position, the Y position, and C position. So let's go to the tool position program, and that is coming here. So find the coordinates of the tool positions in the bed tool holder. So this is a subprogram, tool position. So this is a bit different now, because here I have the parameters by value. So that means that the tool number in this program cannot be updated or changed. And this is an integer. So this is a bit different now, because now I put in a by reference. So I reference the X position of my subroutine to the main program. So I can actually update now my X position variable up here. This X position here, this variable, will be updated with this position here. Oh, I'll come down to that, but any of those X positions. So that will be by reference X position, Y position, and Z position. And then I'll do a select case, and saying that select case, and that is select case and tool number. That is tool number something. Let's say tool number 2 is in the spindle. So it will call select case 2, and it will say, is case 1? No, case is not 1, because case is 2. I say okay, if case is 2, then take the X position and have that as 189.5, the Y position and the C position, and update those 3 variables. So those now the program simply needs, okay, case is 2, I update these variables, and then I have an end select. Now the selection is done and the end subroutine. So this means that the tool position routine is done. It simply found that it was the coordinates of tool number 2. Going back. Here. So now we got our X, Y, and Z positions where the tool is to be placed. Again, I do a code, G53. It will still be in traversing speed because G00 is a modus. So it's a G00, G53, and go to the X with the X position value. And go to the Y, to the Y position, sliding position, and that was 570. So once it's there, do a new code, G53, so that's machine coordinates again, and go to the C, to the tool traversing height. So move downwards, not all the way, but move downwards. Here's a while when loop and saying while it is moving, wait 0.1 second and do when. So it will simply go into this loop and wait until all movement is done. It will pause 0.1 second in this loop, and that is to free up the CPU to process other code. So now we are down at the tool traversing height. Then we activate the airflow signal. So activate signal, airflow, and that means it starts to blowing out air to clean up the bed tool holder for any debris or chips or wood or dust or whatever. So now it's blowing whatever it can. I'll make a new code, G53 machine coordinates. You'll have to do G53 every time. This is not a modus. If you forgot to do G53, it will go in work coordinates, and that's totally different from machine coordinates. So G53 has to be there every time. G53 C and down to the C position. So this is the final position where the tool is to be placed in. Yet another code, G53, now for the Y position, and from the sliding position, slide it into the final Y position. Again a wild when loop. Wait for all movement to stop, so now it's in the tool holder. I will activate the signal for the drawbar to disengage the tool. Wait half a second because it's a pneumatic one, so it has to be pressurized. It has to release it, and I don't have any feedback for it, so a delay function is the only thing I got. So wait for it. Now it's released, and say now G53, go to C and tool traversing height. So move the spindle up away from the tool that now has been placed in the tool holder. So now we need to pick up the new tool from a different location, and that is actually exactly the same as we just did. Now we will see, we'll call the tool positioning subroutine, but now with the new tool. So this would be tool number 3. We just placed tool number 2, so we will call it with number 3 and find the XYZ positions for tool number 3. Go to G53 X and Y position, X with the X position and Y with the Y position. Wait for that to be done and go to the C position. So that is the engagement. Move down to disengage. That is wrong. That is move down to engage the tool. Wait for all movement to stop. Now I simply deactivate both the drawbar and the air blow. So that means the air has been blowing the entire time from dropping the tool to picking it up, and that's simply to clean everything there. You can do whatever you want with the timings of this. So now the drawbar is disengaged and it's clamped the tool. The air blow is turned off, so now the tool is in spindle. Wait half a second for the drawbar to be completely depressurized and engaged. Now to move the tool out of the bed holder, G53Y, and move it out to the sliding position, and move it up to save C. So now we got the new tool in. We moved it away from the bed holder, and now we tell MACH3 that the new tool that is in the spindle is the set current tool with the new tool. Wait for the DRO to update and exit out of this subroutine. Phew, that's a long way. So now we got the new tool in the spindle that needs to be probed. Away from the tool change routine. So we are somewhere up here. Call the ATC. Then I put in a safety precaution again, wait for everything to complete. So now we need to get into position over our fixed tool plate. So here I'll write in a message, coordinate system number is, again this is for debugging purposes, this should be 253 now. Do a code G59 P and the coordinate system number. So this 59 is changing the work coordinate system to P253. Now I do a machine coordinate move rapid to C0. So that's the absolute top position of my spindle. Wait for it to complete. Write a new message for the X position and Y position. G53, G00, and move the tool to the touch plate location. Careful here, because these X position and Y positions are not the ones coming from the ATC. Like I said, remember it can only update the ones that you reference. So these are the fixed touch plate positions. I should have made something different for these variables. X position touch and Y position touch or something like that. This could be very much confusing. Sorry about that. But it's working though. Wait for it movement to complete. Then I'll zero the Z-axis DRO. So set ORM DRO Z-axis to 0. I don't know if there's an OEM button press for this. I simply just write 0 to the display. Wait for the DRO to update. Now we start probing. So message, the C probe start. I just wrote in a debug message again, so it starts from the -100. So this is the G code, G53, G00 to C, and the probe start. So that's -100 millimeters. Wait for it to complete. Change the feed rate. So G01 feed rate. I'm not sure actually I need G01, but that now I'm absolutely sure that I take it out of G00 modus. So G01, so that's feed modus, and the feed rate is probe feed 1, so that was 300 millimeters per minute. This is the code for probing. So code G31 in the C direction and all the way down to the C probe max. So if for some reason the probe doesn't hit the touch plate within the C probe maximum value, it will stop at this value, and it will anticipate that this is where it hit. It still will not tell you that it didn't hit the touch plate. It will just write whatever the C probe max value is. So make sure that this value is big enough. A while when loop. While it's moving, wait for the probe to be done. Now I take and read the probe distance and the probe distance is hidden in this getVar 2002. So that is the Z-axis probe touch point. I store that in the probe distance and I write it in a message that the getVar 2002 is equal to this and this value. Again, a debugging message. So now we need to do the second probe and say we will need to reduce the speed. So a G00C and probe distance plus the Z retract. So that's the 2 millimeters that it will retract from the probe from where it touched the touch plate. Code G01 again, feed modus with a feed rate of probe feed 2. So that's the second feed rate. Code G31C and the same C probe max. So this will probe with a reduced speed, and we wait for it to be completed. I read the probing distance, and I message it to myself, so I can see that you will be able to see a small changes, but I think it's down to my experience is thousands of a millimeter change here. So perhaps you could use just one probe run. My machine is not that precise. I would say within hundreds of millimeters, that's sufficient for my machine. But now, nevertheless, it's made for 2 probe runs. So now we got the actual length of the tool. So now I do the set tool param. So that's a code telling MACH3 tool table database that you need to set up a tool parameter. And the string is that first you need to set the current tool number. So that's number 3. So that will be 3, 2, and 2 is the code for C offset, tool length offset. So for tool number 3, set tool length offset to this value. Now my machine has approximately 150 millimeters from the top to where my regular tools are probed. So I take the probing distance of the second probe run and I simply add 150 millimeters to it. Now this is some kind of a hard-coded value that I just found and placed, and that means when I look at the tool length offset on MACH3, it will be around -5 to +50 millimeters looking at the screen. And that's I won't say important, but it's quite useful, because once you deactivate tool length offset and you have a huge length or an offset, you might end up that you're out of bounds or you hit a soft limit or something like that. The 150 will be depending on your machine. I tried to write a small thing about that. So you could add whatever or subtract whatever you need to do for your machine. Wait for the tool parameter to update. Then I found by mistake or whatever that it didn't actually update the tool table database. You need to save it also. And the do OEM button 316 does precisely that. So you'll need to save it. You'll need to make a call and save the tool table. I actually thought the set tool param did that, but it only updates it and then you need to save it. Code G53, go to G00 and almost all the way to the top after the probe. Once it's done probing, reactivate the G54 coordinate system. Now I didn't read what kind of coordinate system you're working on, but this code always sets it back to G54. So if you came from something different, it will set it to G54. Beware of that. And that was the end of the probe routine for the first tool. So that means the end of the subroutine is done and it returns to the main program. So that was tool number 3. Blah blah blah. And I need to figure out where it comes in, and it comes in here. So what it did call the probe. So this is where it came from, and now it returns to here where my marker is and starts executing code from here on. So that means that the next thing it does, it takes the current tool num and add 1. So it came from number 3 and adds 1, so that now it's 4. It needs to process tool number 4. And it says when, so it goes back to the while loop and checks it and say while the current tool num is 4, is that different from the last tool num, which was 5 plus 1? So that's 6. Yes, that is different. Alright. Call it the probe routine again with the current tool num, which now is 4. And it runs the entire process of changing the tool, probing it twice, returning to here, saying now the tool was 4. Alright, add 1 to it. Now it's 5. Alright, I'll check it again, and 5 was this last one that needs to be checked. So it says went, and then checks up for the while again, saying now the current tool number is 5. Is that different from the last tool number, which is 5 plus 1? Yes, it is different. Alright, I'll call the probe routine again, saying now I'll need to probe current tool, which is 5. Runs through it again, comes back, adds 1 to it, and now it's 6. Goes back again, checks it, while current tool number is that now that is 6. Is that different from the last tool number, which is 5 plus 1? No, it's not different. It's actually equal to each other. So it's not different. And as long as it's not different, then it simply goes out of the when loop, it cancels it, and it's done. And actually the all this if routine is done. So that means that the probing routine is done. And it goes down here and say, alright, we're done. Reactivate the tool length offset with the current tool, which was 5. So it will re-engage, wait for the DRO to update, and we're done. So this was I hope you can pause or step back or whatever. Otherwise, write me a comment or note or something if you need. You have any questions or why I did this and why I didn't do that and stuff like that. Hopefully you can read a lot of it in the text I wrote. What I did while trying to do a very basic code and say code G00, do something and try to execute it, and then simply stepwise build it up with if statements and reading on the forums and trying to add incrementally every time you get something to work. Yeah, that's a good thing. What really bugged me and what it took me quite a while to find out is that the distance in the probe is not compensated for with the tool length offset. So this one you'll need to deactivate the tool length offset. And another thing, yeah, actually the tool length offset is really the root of much evil in this. So if you can deactivate this as soon as possible. So, well, thank you for your time, and I hope you learned something about this. Subscribe, write me an email, comment. I'd like to hear from you. Thank you. Have a nice day.